Continuing in Unit 10, we're in Chapter 9, and this is Section 9.4. We'll be talking about special right triangles. Our goal is to find missing side lengths in right triangles, and there are two types of specific right triangles we'll be working with because they have properties regarding the angles and the sides. The first one is a 45-45-90 isosceles right triangle. Remember, isosceles means there are two sides and therefore two angles that are congruent. Theorem 9.8 says the legs in this 45-45-90 right triangle are of equal length. So the length of a leg is equal to the length of a leg. The hypotenuse is the length of a leg times rad 2. So here we have our triangle. This is a 45-45-90. Because these two angles are the same, our legs will also be congruent. The side opposite the right angle is the hypotenuse. And we're going to be given two side lengths, and we're going to find the third side length using that Theorem 9.8. So we're going to be filling in some charts. You need to pause and draw the chart. So we have our two legs are equal. Our hypotenuse is a leg times rad 2. Now looking back at our picture, remember that C is always the hypotenuse, and A and B are our other legs. So knowing that the 45-degree angles are equal, then I have the two congruent sides. Those legs are congruent. So for number 1, if a leg is 3, B is also 3. And then to get to see our hypotenuse, we're going to multiply by rad 2. So C is 3 rad 2. Number 2, if B, one of the legs is 7, again, those legs are congruent. They have equal length. So A is 7. And then to get to the hypotenuse, we're going to multiply by rad 2. So we get 7 rad 2. Number 3, A, the length of a leg is 10 rad 3. Therefore, B is also 10 rad 3. To find C, we're actually going to do our 10 rad 3 times rad 2. So I'm just going to go off to the side under the number 3 and do some work. Remember that when we multiply the regular number, that coefficient, by the other coefficient, and the part that's underneath the radical, that radicand, by the other radicand. So I'm going to keep my 10 out front. Rad 3 times rad 2 is rad 6, and that does not simplify. So the length of the hypotenuse is 10 rad 6. Number 4, we're going to go backwards now. So if I had the length of a leg, I would multiply by rad 2 to get the hypotenuse. Therefore, if I start with the hypotenuse and I need to come back and find the length of a leg, I'm going to divide by rad 2. So we're going to take 4 rad 2 divided by rad 2, and those radicals cancel. So we get 4. Since the legs are congruent, A is also 4. Same chart, moving over to number 5. Again, the legs are equal, and it may be very helpful on these charts, especially on the worksheet, to put an equal sign between the two legs on your 45-45-90 right triangle, and then a times rad 2 from a leg to the hypotenuse. This one, again, we're working backwards. We're starting with the hypotenuse, so I'm going to take the 12 rad 10 and divide by rad 2. Again, our coefficients divide. We only have a 12. We can have a 1 on bottom, so we get 12. And the parts underneath the radical, the radicands divide. So 10 divided by 2 is 5. So the length of a leg is 12 rad 5. The other leg is congruent. It is also 12 rad 5. Number 6, the length of a leg is 6 rad 2. The other leg is congruent. To get to the hypotenuse, we're going to take our 6 rad 2 times rad 2. Rad 2 times rad 2 is rad 4, which comes out as a 2 because the square root of 4 is 2. That multiplies by what's up front, and 6 times 2 is 12. Number 7, if one of the legs, B, is 9 rad 6, the other leg is congruent, so it's also 9 rad 6. To find the length of the hypotenuse, we're going to take our 9 rad 6 and multiply by rad 2. So 9 rad 6 times rad 2, so we have 9 rad 12. 12 will break apart, so we need to do our factor tree. 12 is 4 and 3. 4 breaks to 2 and 2. So we have a pair of 2's and a lonely 3. When the 1, 2 from the pair comes out, it's going to multiply by the 9 that's already there. Remember, we keep the 9, and this is 2 rad 3. So multiplying 9 and 2, we get 18 rad 3. So again, we're using those properties that we talked about in our unit on radicals. We're going to go back and review some of those as we work these problems. Number 8, if the hypotenuse is 14, to go backwards to the length of the leg, we're going to divide by rad 2. 14 is a regular number. Rad 2 is underneath the radical, so I can't divide those, but I also cannot leave the square root at the bottom of a fraction. So we're going to rationalize the denominator. Remember to rationalize, you multiply by a fraction that's equal to 1. The math trick here is how you write the 1. So we take the square root and we write it on top and bottom. Multiplying across, we get 14 rad 2 over rad 2 times rad 2. This would be rad 4, but the square root of 4 is 2. And again, we can simplify those coefficients. So 14 divided by 2 is 7 rad 2, and the legs are equal. So we get 7 rad 2. Be very careful working with your radicals. Okay, that's how we set up the 45, 45, 90 right triangle. Let's move on to Theorem 9, our 30, 60, 90 right triangle. In a 30, 60, 90 right triangle, let me go to the picture. We have our 90-degree angle, we have a 30-degree angle, and we have a 60. Now, opposite the 90 degrees is the hypotenuse. We've talked about the hypotenuse is the longest side of the three. Now, in our legs for a 30, 60, 90, our legs are not congruent like they are when the two angles are 45. One's going to be larger than the other one. Opposite your small 30-degree angle, you have a shorter leg. So we're just going to call this the short leg. Opposite your larger of those two acute angles, the 60 degrees, this will be a longer side, so we're going to call this the long leg. As we're working through our chart, we'll call the short leg B, the long leg A, and the hypotenuse C. So going back to our theorem, the long leg is rad 3 times the short leg, or the short leg times rad 3. The hypotenuse is twice as much as the short leg. So if I have the short leg, it's going to be very, very easy to get those other two sides because we're multiplying the short leg by rad 3 to get the longer leg and the short leg by 2 to get the hypotenuse. If I start with either one of those and need to go back to the short leg, then I'll divide by rad 3 if I'm starting with the longer leg. I divide by 2 if I'm starting with the hypotenuse. Okay, so let's look at our chart. So B is our short leg. A is our long leg. And C, as always, is our hypotenuse. To go from the short leg to the long leg, we're going to multiply by rad 3. If I have to come backwards, then I'll divide. To go from the short leg to the hypotenuse, we're going to multiply by 2. Again, if I have to come backwards to the short leg, then I'll divide. So we're going to start with our short leg is 4. Our hypotenuse is times 2, so that's 8. Back to the short leg is 4. Our long leg, we're going to multiply by rad 3. So 4, rad 3. We're always going to start, if we can, with that short leg, because then going to the long leg and the hypotenuse, we multiply. If our short leg is 7 and number 2, to get the hypotenuse, we do times 2, so that's 14. Again, short leg is 7. To get to the longer leg, we're going to multiply by rad 3. And remember, when we multiply a whole number, a regular number that's not underneath the radical, times a radical, we just put those next to each other, the same as we would when we're multiplying 7 by x. Okay, let's start with our hypotenuse. Now, to go from the short leg to the hypotenuse, we multiply by 2. So if I'm going to go backwards to the short leg, I'm going to divide by 2. So 10 divided by 2 means the short leg is 5. To get from the short leg to the long leg, again, we're going to multiply by rad 3. So we get 5 rad 3. Go ahead and try number 4. Pause the video. For number 4, to go from the hypotenuse to the short leg, we're working backwards. So we're going to divide by 2. 24 divided by 2 is 12. To go from the short leg to the long leg, we're going to multiply by rad 3, so 12 rad 3. Let's look at a few more examples with our 30, 60, 90 right triangle. Again, we said B is our short leg. C is our hypotenuse. A is the long leg. This one, to go to the hypotenuse, is times 2. To go to the long leg, it's times rad 3. So our short leg is 2 rad 5. We're going to go over to the hypotenuse first. So I'm going to multiply by 2. So 2 rad 5 times 2, multiply the 2's, and we get 4 rad 5. To go to the long leg, I'm going to start with my 2 rad 5. And we're going to multiply by rad 3. Now remember, if we have two radicals, we multiply the numbers underneath. So I'm going to keep the 2 out front. Rad 5 times rad 3 is rad 15. Number 6, again, we're starting with the short leg. To get to the hypotenuse, I'm going to multiply by 2. So 4 rad 3 times 2. 4 times 2 is 8, and we keep the radical. It's like saying 4x times 2 is 8x. 4 rad 3 times 2 is 8 rad 3. To get to the long leg, we're going to take our 4 rad 3 and multiply by rad 3. But rad 3 times rad 3 is rad 9. Square root of 9 is just 3, so 4 times 3 gives us 12. Okay, let's work on some where we go backwards. I'm going to start with the long leg. I know the long leg for number 7 is 6 rad 3. Now, to get from the short leg to that long leg, we would have multiplied by rad 3. So if I'm starting with the long leg and need to go back to the shorter leg, I'm going to divide by rad 3. The rad 3's cancel, and my short leg is 6. Then, just like normal, to get to the hypotenuse, we multiply by 2. 6 times 2 is 12. Let's try the same thing with number 8. We would have multiplied the short leg to get the long one. So to start with the long leg, we're going to divide. So 9 rad 6 divided by rad 3. The 9 stays, and under our square root, 6 divided by 3 is 2. Then to get to our hypotenuse, we multiply by a regular 2. 9 times 2 is 18, and we keep the rad 2. Let's try number 9. We're starting with a long leg of 9. So we'll be dividing by rad 3. Those don't divide because one's a radical and the other one's not, but I cannot leave that radical in the bottom of the denominator. So we're going to rationalize. Multiplying straight across, we get 9 rad 3 over rad 9, which is 3. Our coefficients, our regular numbers, are going to divide. 9 divided by 3 is 3, and we keep the rad 3. To get to the hypotenuse, we're going to take this 3 rad 3 and multiply it by 2. Multiplying the regular 3 by the 2 is 6, and we keep the rad 3. So we'll be working a lot with what we've learned about those radicals. A couple special pictures that will come up. The first one is a square. In our square, if I draw on one of the diagonals, or one diagonal from this vertex, this is my 90-degree angle. That diagonal actually bisects the angles. This is a 45, 45, 90, so the legs are congruent. I could call this x. The hypotenuse is x times rad 2. In our equilateral, I'm going to draw the altitude. Now remember, equilateral, if I have 180 degrees in a triangle and I divide it into 3 equal angles, each one of those angles started out as 60. That altitude is going to bisect the top angle. So here we have a 30, 60, 90 right triangle. The short leg across from the 30, we'll just call x. The long leg across from the 60 is x times rad 3. And the hypotenuse across from the 90-degree angle is twice as much as the short leg, so it's 2x. So this is the hypotenuse. This is what we call the long leg, and this is what we call the short leg. We'll be working on handout 10D and review 10.1, the front side of 10.1 only. Now make sure you're doing all of 10D. 10.1 is the front side only.